All right, let our journey begin, right? So, welcome back. If I'm in your first class, hooray for me, or not hooray, right? Depending on your perspective. But it is a really good time because your lives and your careers and all this stuff is progressing, right? I mean, the job or the goal, if you ever want to say, is in college is to get out eventually and start working and have a productive income. So this is just a step, right? So I know there's long faces, summer's over, yada, yada, yada. I had that with my kids this morning. But the reality of it is like you're evolving, you're getting more out of it. And so it's a good thing. And change oftentimes can be a good thing. We're really afraid of it, but don't be. Try to embrace it because change is inevitable and it will help you have a better attitude about it. You'll be able to see some changes in perspective. So, like I said, welcome back. I'm Paul. For those of you who haven't seen me, I'm not Professor Villeneuve or anything like that. It's just Paul. That's fine. You can call me Paul. We extensively in this class, because you'll notice that I always have Zoom running for this class because there are a lot of people who take this class remotely. So they may or may not be in the live class, but I have to record the videos so that they will be able to get the same content that you get. And the other advantage is, and so I've done a lot of grad classes online, and I found that even if I would go to a live class, I always found rewatching the video helped cement some of the concepts that I was learning. So I would always go to the live class because I could ask questions and I could really focus. But then maybe after I'd start doing the homework or reviewing material, I might rewatch the video because once you've seen material once, if you see it again, you pick up a little more, you pick up something different, and you get more familiar and better with the material. And so by having the videos available to you all, it actually gives you that opportunity if you want to preview or review the videos. The other advantage is when you watch the videos in live time, right? A minute is a minute. But I always upload these to YouTube. And if you haven't played with YouTube, which I'm sure you have many times, you can adjust the speed of playback. So you can figure out how fast to rewatch the videos because it's not the first time you've seen it, or you can skip parts, or you can do different things. So you don't have to spend an hour and 15 minutes rewatching a video. You could maybe do it in 40 minutes or 45 minutes. So it's just a way of improving efficiency and maximizing your time. That doesn't mean that I suggest don't coming to class, not coming to class, because it really is the best opportunity for you to get the most out of it. And what I mean by that is coming to class, you're going to be engaged. Even if you're tired, you're still going to be in a class where people are interacting. And then the hope is you'll get more out of it. So this coming to class is one of your best ways for being successful in this class. It's not too early, right? 9:30 in the morning is not crazy early, but it really does help you to come to the live class. So I don't hold a gun to your head because again, we do this online. And so some people are taking it, asynchronously and some are not. So it'd be hard to enforce a policy where you have to come to the live class. I know Jude in the past, for those of you who don't know, Jude, my colleague, she's on a sabbatical this semester. So you won't see her hardly at all this semester. So I know that bums people out, but she's still around. She just won't be coming to campus all that much. She's taking a well-deserved break from teaching. She hasn't had one since I think she was on maternity leave with Josh. And Josh just graduated and moved to the Virgin Islands. So for those of you who don't know, that's her son. So some of you have met him, some of you may not have, but there's been a lot of changes in her life. And so it's good. It gives her a little bit of an opportunity to refresh, try learning some new things. It's not like it's a break from working. She's still working, doing a lot of things, but she's going to learn new material. When you're teaching classes and you're grading, sometimes it's hard to learn new material because you're just trying to keep up with what you've got. So for me personally, I do a lot of learning because I do a fair amount of active consulting. In fact, this summer I was doing some projects for people in Virginia and also in New York. And so some of the stuff I've been doing in New York is a busy, busy, busy state, a lot of people with a lot of growth. Even though you hear about Texas expanding, New York continues to grow. And so there's a lot of development. And when that means a lot of development, you need a lot of electricity and power, right? And that's kind of my forte or expertise. And so they're talking about building massive, massive infrastructure upgrades. I worked on a project that's probably going to cost, when it's all said and done, about $500 million, which doesn't sound like a lot, or maybe it does. I don't know your perspective, but that's basically for one tiny little substation on Long Island. I also work for another project, again, on Long Island, but this is way, way out on Long Island. If anybody's familiar with the Hamptons, it's very she and posh. This is such a rich area that they will not allow like a standard substation. It's too ugly. So you have to buy what's called gas insulated substation or switchgear. So you can put it in a building. So you just see a brick building or a metal building. So it kind of blends into the scenery. They do not allow new substations to be built. You can't see ugly steel and wires and stuff like that. If it's existing, too bad, right? You can't change that. But they're talking about interconnecting to the substation, and I can't remember the size of the project. It's 40 megawatts or 60 megawatts, and they're probably talking 100 to $200 million for this substation just to make it look pretty. So what that tells you is the project's not going to get built, right? 40 to 60 megawatt project with just upgrades to the infrastructure for the utility is probably more than 2 to 3 times what the project would actually cost. And this is a battery storage project, so it really is just going to change things a lot. So I've done a lot of that this summer, and so I get to learn a lot, right? Share all that useless information about if you live in Southampton and you want to do electrical upgrades, you better make sure they look pretty. So anyway, I get to do a fair amount, and then hopefully I can bring that knowledge back to you all. It's different than the stuff I do now because they have me doing a lot of management of projects and stuff like that. So I don't get to do as much engineering as I used to do, but that sometimes is a good thing. It's change, right? It's like you can actually do different projects. So everything will be available on Brightspace. And you should, if you haven't, please let me know. And we'll go through this in a minute. And you'll see why I'm doing this now. But you should have access to the Brightspace folder for this class. And all correspondence, homework, notes, everything is available to you or will be available to you on Brightspace. So if you haven't done so already, anytime I post something to Brightspace, you can have a notification sent to your email or maybe even your text number. I'm not exactly sure, but anything that gets posted there, you'll get a notification, and that encourages you to check. There's also a calendar feature, so you can check due dates and stuff like that. There wouldn't be anything due, right? Because this is our first class, but you can learn about that. And also in here under, and your version looks a little bit different than mine. Let me see. I'll change this to a student so it looks a little bit different. Get this out of the way. And you as a learner, so this is what you should be seeing for the most part. So you have announcements, and then don't worry about the dates. Those are just dates that I have to move around. So I just have some placeholders in there now. But you can see I have a live class link. So this is the Zoom link. If for some reason you're sick, your car is broken, you overslept, then you can always come into the live Zoom link. Again, if you can, it's always better to be in person. But if you can't for one, good reason or another, you can always use this link. And this link is going to be active throughout the semester. And so I have the link going right now, but I'm also, if you can see here, that little dashed in TV land, you can't see it, but there's like a cloud with a red dot that's increasing or decreasing. That means I'm recording this class. And so when Zoom processes the video, then I download it, I upload it to YouTube. They have to process the video and I post the link, and then you're able to access it, usually within 2 to 3 hours after the class is over. So the link is not instantly available. It takes a few hours to get up there, but it will be up there by the end of the day. If for some reason it does not, please email me because I may have uploaded to the wrong folder. I'm teaching 4 classes this semester, so sometimes I get things mixed up a little bit. But let's go to the syllabus. Where is the syllabus? So under content, you'll have the syllabus here, and we'll go through this quickly. Before we do that, let's actually do a quick attendance. If somebody's name is not on this list, then I have to add you manually because you only get added to the Brightspace folder if you're on in Main Street. I can't easily add folks, so it should automatically have populated you once the class is active. But if not, then I would just need to know. So Matt Brown, Cole Brown, Connor Burke, Aiden Davis, okay. Connor Devin or Divine. Is it Devin or Divine? Divine. All right, thank you. Kane. Yeah, over there. Luke Lapp. Yeah. Jimmy Longy. Robert Morrison. Okay. And if you prefer nicknames too, just let me know. Andrew Monroe. Brandon Ringette, I thought I saw him walk in with a fresh haircut. Braden Saucier. Did I say that correctly? Saucier?
Yeah.
Well, I can't tell my last name in French Canadian, so I'm hoping to say it the right way, but if you prefer a different way, okay. I could say really French, but you probably don't want that, so. Henry Sheff.
Here.
Yep, online, I saw that, sorry, Henry. Arthur Smallage is not here.
No, I'm in your computer.
Oh, you're here, okay. Sorry, Arthur. I didn't see you on Zoom.
No, I'm here.
Jaden Spalding. Oh, here. Austin Speed. Wyatt Stanley. Homa Tatey. Yeah. Drew Turnbull. Elijah Weston.
Here.
All right. And Cully. Doing that remote. Okay. Perfect. Did anybody, is anybody's name that I didn't mention? Either in TV land or called out? I just printed this like 10 minutes ago to make sure I had the latest and greatest class roster. So again, if you're not on the class roster, you don't get added to the bright space unless I know about it. So kind of important we get there. So, okay. So pretty standard syllabus. I will teach the lecture. Mark Mishu, this will be his second time covering the lab. He does a great job. He's a very likable guy. You'll get to meet him soon enough. He's also covering Digi for Jude, 275, I think. So we get to see a little bit more of Mark. Here's a recommended book, and we'll get into that in a little bit. Course outcomes. So this class really is about trying to take all that knowledge that you've had in your previous circuit analysis classes, and it's varied, right? Some DC, some AC, maybe some electronics, but we're trying to change it now so that it's kind of written from or understood from more of a basic perspective. And what I mean by that, it doesn't mean it's easier. It just means it goes down to like the base physics. And so we'll do a lot of time domain analysis as opposed to steady state analysis, but we'll see how we can apply those quite a bit. We're also going to look at transient characteristics. And when you hear the term transient, that just means time varying, right? And whenever you think of time varying, you think derivatives or integrals. So how many here have taken class in differential equations? 3 of you? Yeah, so it's no longer required in the EET program to take differential equations, and we don't need to solve differential equations using the differential equations technique. What we'll do is we'll introduce something called Laplace, which will allow us to convert differential equations to algebraic equations, and they're much easier to solve. And the inside joke, if you will, for engineers is that no engineers solve differential equations. They use Laplace to solve differential equations because it's so much easier. So we'll get into that. Understanding the the Laplace takes a little bit of time and we'll talk about that when we do partial fraction expansion, but eventually it'll get easier and easier and easier. So it'll be kind of second hand. So some details on the exam, and I don't know why some of this stuff is printing a little weird, but 3 prelims, just like every other class, and a final. Lab sessions, highly encouraged to do what you can in MATLAB. And we'll definitely be doing this stuff in multisim. So multisim, you can go to get a student version. I think it's 40 or 60 bucks. If you have a partner you like to work with, go for it. And then you can share the costs because you only need one version of it. But make sure you get the student version. You don't need the high-end version. I know John and Jude have used different applications in the past, but it doesn't really work all that well for a lot of the simulation stuff. And so we've talked about trying to standardize on something. Multisim probably, it's a little more, you can do more advanced stuff with it, but it really does have a lot of really good features. And so that's why we use multisim. MATLAB, and I know some of you have had me in previous classes, MATLAB to me is just a calculator. That's all it is. It's a fancy-dancy calculator, but it's a calculator. And so when you enter stuff in your calculator 3 times 5, you'll do the same thing in MATLAB. The advantage for MATLAB is you can see it all on a screen that has, 80, 90, 100 characters across. And it's easier to troubleshoot than on your calculator. And so we'll be doing calculations in this class in MATLAB. So I'll actually show you some of the syntax. You don't need to be an expert at it. It really is just a calculator. And why I'm saying this is because you can actually use MATLAB for the exams. So you'll be able to spend some time learning it if you want, and then use MATLAB as your calculator. But you're not required to. You can still use your regular old calculator if you want. MATLAB's free. It's a free download if you're a UMaine student. You just go to umaine.edu. Well, we can do that really quickly here. If you go to umaine.edu/IT, and then under, they keep changing things a little bit. They used to have a download tab, but let's try here. And we don't want that. Where's our software? They completely adjusted things. Oh, here, UMaine software. Sorry about that. And there it is. It's a free download. So as long as you download and log in with your Main Street ID, your .main at main.edu, it's a free download. Be mindful though, it's about a 4 to 5 gig download. Okay. So if you are going to download it, make sure you have space and make sure you have a reasonable internet connection. I used to tell a joke about doing it on a dial-up, but does anybody here actually use dial-up anymore? Probably not, right? I don't even know if it's available. AOL just ended their dial-up service, I think, in the last month or so. So really, really, really good. Mathematica is another program, but MATLAB is so much easier. I even use it in industry still. Let's see. Some grading metrics you can take a look, or rubrics. These are the boilerplate syllabus statements. So you can take a look at all these if you want. They have some details on here. And then just some high-level course outline stuff. All right, that's what the syllabus has. Questions for me? Yes. Nope, you can download it. I think you do have to pay for it, but if you go, so it's NI, National Instruments Multisim. It got bought out. It used to be a little bit cheaper. I think it's called Studica. Yeah, if you go to Studica, all you need is this, and I think it's $60. This is the last time I checked. $69.95. What's that?
The number got bigger, it started at 48.
Oh, wow. Sorry. Inflation. You will need it for the labs, and you can decide if you want to do it for your lab, your homeworks and stuff like that, if you want to simulate it. But you should be able to get financial aid because it is required for the lab. Okay. But again, if you find a lab partner, then you can share the costs. So all of you two are pretty savvy on the internet, so you might be able to find cheaper versions. If you look hard enough, they might have cheaper versions out there. I don't know. But the $69.95, I think, is the cheapest legal one that I've been able to find. So I'll just leave it at that. Other questions? No? Anybody want to share what they did over the summer? It's always nice to get some personal. Anybody do anything fun? Anybody work? Anybody do any good internship jobs, or anybody want to share? Who?
I work for Power Engineering.
Ah, yes, in Hollowell.
Yeah.
Yeah, so for those of you who don't know, Power Engineers loves to hire our students. They have an office in Hollowell, which is just outside of Augusta. They used to have a bigger office in Freeport. I don't know if that's still the case anymore.
I think they do, but I guess a lot of the people there work remotely.
Yes,
Not a lot of people going, I guess.
right.
I heard, but
So Power, tell them about Power. If the
uh,
name is not obvious enough, right?
it was good. They do both like the physical side of, or I worked in the substation group, so I did PMC. So I was doing like a lot of drafting work, but they also have like physical side to it. And, yeah, good group guys. Good time.
Everybody understands substation, physical, and PNC? Who does not? Who's the honest person who does not know what substation PN? Fair enough. I'll add a little bit of background and you can correct me. because I am a PNC engineer, which stands for protection and control. And normally when you do protection and control, you're involved in like high level one line development, like designing the plant for its meeting some basic specifications. But the biggest thing about electrical systems is they experience faults. And so you've got to make sure that the system is protected so it can analyze and detect faults, but then it actually can trip and isolate the faults. So that's the protection and control side of things. It's the fault analysis, but also some operations, like sometimes you get open breakers or closed breakers. Those are things. Where the substation sort of general one is like that big, thing that's, out in the woods essentially, and it has steel, it has breakers, it has transformers, it has all kinds of different things. And so normally there's a physical design group that actually designs substation, like literally figures out, I need a steel brace here and I need a support for this bus bar, which is aluminum. And then I need to connect things to the breaker. So they have to put the foundations in and the grounding. And so there's quite a bit of engineering involved in a substation. And one of the things most people don't realize is there's this thing called step and touch potential. You know, in a substation, if you take a step, you could die if it's not properly designed. Kind of crazy, right? And what I mean by taking a step, you're not walking off a cliff. I'm talking about walking on level ground. If a substation's improperly designed, if you take a step that's about 3 feet, if there's a fault occurring at the same time you're taking a step, the current going to ground could be 50,000 amps. I've seen as much as over 200,000 amps. And you get 200,000 amps going through a ground grid that has an ohm of resistance. 200,000 amps time 1 is 200,000 volts. So when you take that step, that's enough potential for the current to go through your body. So the step and touch potential limitation in the substation is it's got to be less than 50 volts. If I go from here to here, or if I'm touching steel, I'm standing here, I'm touching steel, I do not see greater than 50 volts across any part that I'm coming in contact with. So less than 50 volts is usually enough that you won't get shocked or get injured. But old substations, people used to die. Literally, they'd be standing there trying to operate a mechanism and they touch it and they would get electrocuted. So that's one of the kind of the bigger things that has to happen. But yeah, power engineers, they do a great job. They've had some of the company at Hollowell actually are some of our alum. Like Adam Benedict, I think runs the office now. He was one of my students back almost 20 years ago. So a good guy.
Yeah.
So really good people. And they always are looking for really good interns. So this is a spiel. What's happening in October for those of you who are new to campus? Can you share with those folks?
No.
Yeah. Engineering job fair. Get your resumes ready. Career Center is free. They'll help you with resumes. And we have 130 to 150 companies looking specifically for engineers. So talk about being ready, right? You literally are looking at a job fair, and it's just for engineering graduates. It's not the general one that happens in the fall. They're just looking for engineers. And so they're trying to woo you. So they come in October because they know by February, it's too late. You've already got a job. And the best thing about the engineering job fair is if you get an internship, like they already know him. Power already knows him. And they've already made a decision. We're going to bring him back next summer, and then we're going to make him a full-time offer. So he doesn't even have to look for a job when he graduates. As long as he does a reasonably good job, at the internship, he should be in pretty good shape. An internship is basically a trial job. They see if they like you. They give you 25, 30 bucks an hour, and they have you work through the summer, and there's no commitment after that. So they don't fire you. So there's no risk with that. And then they can bring you back or not. And most of the time, it's a really good relationship. They've spent $25 an hour. They've got you all trained. You know all their standards. It's like you hit the ground running when you walk through the door. So and most of y'all are juniors, if you haven't had an internship yet, you really want to be thinking long and hard, because all those interns, they usually always have jobs. Like literally, like seniors will be coming to us in the next week or two. Yep, I've already accepted a full-time offer from company ABC. And it's September. So 8, 9 months before they graduate, they don't even need to look for a job. They've already got a full-time job. And usually pretty good pay. So something to think about. Anybody else want to share something about their internships or anything like that? How about anybody do anything fun? I went to Montreal for my kid's soccer tournament. That was about it. I went to Montreal. I went to Devon's, Mass. I went to Amherst. which is outside of Manchester, New Hampshire. I went to Burlington, Vermont, all those for soccer. So if you have kids or you do have kids, you get them into sports, just be careful about getting on these quote unquote elite travel teams because it's a lot of travel, like a lot of travel, exhausting amount of travel. So and that's just one sport. He also plays basketball. Well, both my kids play basketball. I have one kid who's going to be 10 like in 2 days, and he's a pretty good soccer and basketball player. And I have a 7-year-old who's a madman. Like he just runs with reckless abandon. They actually kicked him out. He was in a grades 1 through 4 basketball camp essentially. And but he's going to be in 3rd grade. 2nd grade, sorry, not 3rd grade. He's going to be in 2nd grade. And they kicked him out because he scored like 36 out of 50 points. And it was just like, you're making all these other kids feel bad. You can't keep doing that. So they weren't being mean to him. He's just like, and it's not a bragger thing, but it's like, he's just making it very difficult to do the class. And what was hard about that is one coach is like, you need to pass the ball and do all this stuff. But then there's this one kid, his name is Ollie Higgins. He's like a 6'10" sophomore who lives in Brewer. I don't know if you've heard of him, but he's a really good basketball player. And he was the team coach for my son's team. And he was saying, Gabriel, drive, just keep driving. And so one coach said, no pass. And this uber competitive sophomore in high school is saying, no, you need to drive and get buckets because none of your teammates can score. So drive. So he was like, drive, okay. Because you want to score buckets, you know what I mean, and do all that. And then the other coach is like, no, you want all the other kids to get better. So they basically said, you're messing things up. You can't really be here because you're just, and again, not a mean thing, but they're like, it's too hard for you. It's making it difficult for them. So they moved them along to a 5th through 8th grade group. So that was kind of interesting. So yeah, I just tell you that because it's a good thing, right? We had a lot of fun with summer sports and summer camps. And I got to go to Colby College because my older son's going to be a 5th grader. And they were at a basketball camp, but he couldn't be a resident. He just got in. So I got to go to Colby College every day, drive like at 6:30 in the morning, and I get home until 9:30 at night because they were long days. And I got to sit there and watch them play basketball, but I was really working the whole time. So that's a really nice campus. If you ever have an opportunity to check it out, it's a pretty fancy campus. So anyway, that's essentially all I did was chase kids stuff this summer. So it was busy. And if you want to talk soccer or basketball, I've learned a lot in the past year. I knew about basketball, but soccer was new to me until now. It's kind of crazy. So anyway, here are the presentations, and I've got a few of them in here. I don't have all of them because it depends on the pace of the class. But I have today, and then I have our next one, which is the circuit analysis techniques. And you will note that when we do circuit analysis, we're going to go at a much faster clip than probably you've experienced. And I'm going to make you think very differently. We're not going to just say, well, some of the voltage drops is equal to 0. I'm going to get you to think about potentials and where does the current go? And can you look at things from a different perspective, from a nodes perspective? And so trying to really do a little review, but really trying to enhance our understanding. So that's what our circuit analysis. We'll do some capacitors and inductors, getting back into that. And the reason why we need to do that is for most of us, when we've exposed to capacitors and inductors, they tend to be a steady state or a DC, like a fully charged condition. We actually have to do these time domain because it's transient. So it's the CD/VDT, it's the LDIDT. We'll look at first order circuits, which is how we would solve differential equations. And then we'll do briefly differentials, but then we'll move into our Laplace, our introduction to Laplace. And then we'll actually do circuit analysis with Laplace. And so really you can use Laplace to solve any differential equation. It doesn't need to be an electric circuit. It could be a mechanical system. It could be a biological process, right? A lot of our stuff in our body is determined or governed by physics. And so you could solve those differential equations of how our body functions using Laplace. But we're all in a EET or some electrical. So it usually is easier for us to understand electrical systems. And so we write things from an electrical perspective to come up with differential equations. And at the end, if we have time, we'll do some Fourier analysis, Fourier series. Okay. So here's the somewhat formal presentation, and I probably won't go another 45 minutes because that's okay, right? It's our first class back, and it's good to introduce. And if we have a few minutes after class, we can certainly, talk about whatever. But here are the lectures, and we're going to be in this room, 131, or you're going to do it online. Here's me, and here's one way to get in touch with me, my email. oop. Sorry. Go back to sharing. Didn't share. I'm screen sharing, so why isn't it there? Let's see, it's Control Alt H. Is that what takes it? Shift Alt H. There's a way to hide this, and I can't remember the Control Alt Shift H. So office hours, 11 to 12:30, but as soon as this class is done, I'll walk down, and then I have my next class is at 12:30, so I might have to leave a few minutes early. But the best way, if you are trying to have a question, is to Zoom me. And here's just a zoomed in version of Zoom. So in Zoom, it's really helpful if you've got contacts set up with you. And so this is just the generic one that I have, but it looks exactly the same. It doesn't matter the version. But in Zoom, you can actually look at the status of somebody if you've already made contact with them. So if you've accepted a contact or you have provided a contact and they've accepted you, you're going to show up in their contact lists and you'll see their availability. So here are what the different icons mean next to their name, and you just have to look, with a little bubble, if you will. If somebody's offline, if you need them right then and there, it's not worth trying. They're not available. So email would be probably a better way to do that. If they're online on their desktop, you have the green circle, which means they're online and actively running Zoom. It doesn't mean that they're available. The example I use is like, if I have a 9 to 5 job and I'm supposed to be in the office from 9 to 5, sometimes I go get a water, sometimes I get a bathroom break or something like that. Sometimes I'm talking to somebody and I can't, it can't be disturbed because I'm having a conversation with somebody else. So if it's available and they're online, it's worthwhile to send a chat. Are you available to do a whatever 5-minute discussion? And you send that, and if they are, then you can actually right click and set up a meeting with them right then and there. This happened to me yesterday. There was a student who was trying to get a hold of me, and I'm like, if you have Zoom running, I'll send you a chat request. And we got the chat request set up. So as soon as it was available, we did a meeting live and in person over Zoom. So that works really well. Then you have the mobile app. If you want to do mobile, that's less effective because you may not be able to see me and I can't share my screen. So the desktop one is the best version because if I write something, I can share my screen and show you what I'm writing or point out certain things. Whereas with the mobile one, it's not as effective. There's the away. So if I got Zoom running, but I haven't been using it for a while, it means that I'm away for a longer period of time. I can also set do not disturb, like if I really need to focus, or if I have a 1-hour meeting with somebody and I don't want to be disturbed, I can set a do not disturb. I can have a camera, which means I'm in a Zoom meeting or I'm presenting. So I'm definitely not available at that time. You can also do calls. You can do a calendar event. So you can sync your Google Calendar with this. So it'll tell you that it's in a calendar event. So you might not be available. And then if there's an error, it just gives you the alarm. So I tell you this because it really makes your life easier. And as the world moves to a more, and more online version, that doesn't mean working remotely. That just means that you're meeting clients and you're doing meetings via Zoom or Teams is what most people probably are familiar with because that's more of a business standard. Then getting familiar with these technology and using these tools the way they're intended helps makes things really effective. Here's the first book that I recommend, and I hope I'm not inflating the price, but how about this? We'll say between 20 and 30 bucks is what you can buy this Shomes Outline series. So this is just a high-level review with loads and loads of problems, okay? You can go to Amazon and buy it. I think you can buy it as a PDF, or you can get the hard copy or the paper copy if you want. But they have tons and tons of good problems in here. So I use a lot of the problems that are in the Shomes Outline series. This book here is if you want to get a lot more detail, like a lot more behind the scenes. This is engineering circuit analysis. It has some good examples. You don't have to get this book. This is like a $200 book. So this is something you need to contemplate really buying. But if you want to get a further in-depth understanding, getting this book does a really good job of giving you that level of detail, particularly if you can read a book and process it and go from there. Some people can do that well, some people can't, so that's worth thinking about. This is multi-sim, and this is why multi-sim is so good, because I can draw circuits or I can build circuits kind of like I would draw a diagram, right? An electrical connection diagram. You can see that I've got comparators in here. I've got some op-amp circuits, LM741s. I've got power supplies, grounds, resistors, and I'm just connecting all those things. And then I can either monitor the output with an oscilloscope, so I can literally drop an oscilloscope and connect it and look at the waveforms on the screen, or I can use a multimeter, which is just like a typical fluke meter, or over here, I can actually use a meter to display real time what's happening in my results. So again, I really like multi-sim because it does a pretty good job. It also has a very large component library. So you can get tons and tons of information. The biggest reason why we like to use it here is because you can do transients analysis very, very easily. Works super duper well. Excel. I like to do a little bit of stuff in Excel, and so we'll cover that a little bit in this class, because if you know how to use Excel, you are a step up in the industry. Being able to be comfortable with Excel to do some simple basic calculations, it's really good. And it's also really good because you can make beautiful graphs. So in the past in industry, if I had to do more complex calculations, I would do everything in MATLAB, because you can do calculations really easily in MATLAB. And then I would just export the data into Excel, and then I would make beautiful plots in Excel. So Excel really, for engineers, makes wonderful plots. It's easy to use, or relatively easy to use. So highly encourage it, because if you have a picture, you can tell 1,000 words. Okay, you can give a lot of detail in a figure or a chart in Excel than you could if you had to write it out. And then MATLAB is just a super duper calculator. That's all it is. That's what we do it for. You can actually write scripts in MATLAB to do things over and over again, but it works just like a calculator. So why simulation software? Well, if you're doing everything in steady state, unless you're building something really fancy, then you don't have to worry about it, right? You can just go get some components and you can put them together, and then you have your circuit. But if you're trying to do things, that take lots and lots of components, or you don't know if a specific component is going to work, you can simulate it. And you can save a lot of money and time by doing a software simulation. So you're seeing more and more work that's done being simulation. And the biggest reason too is because it's cheap, right? You can have a computer, a desktop computer, that can run all kinds of different simulation programs, and you can get whatever results you're looking for. Again, the results are only as good as how the software runs and what information you enter, but it usually means it works really well. So we simulate in this class because some of the systems are hard to pick up transients. Like it's really hard to see a rise time and be able to calculate it unless you're sitting there. If you're in a lab and you're trying to stopwatch things, it can be very inaccurate. So doing simulations when you're doing time domain stuff is really, really helpful. So, excuse me, here's a course description. A lot of stuff you've already seen, right? Kirchhoff's laws, KCL, KVL. We'll introduce diffie-Qs, mostly Laplace. We're going to do dynamic systems. What is a dynamic system? You have two types of systems, dynamic or static. Dynamic is a changing system, right? A static is a fixed or non-changing system. Static systems are much, much easier to solve. But in the real world, a lot of stuff is dynamic. Even when you plug your laptop into the wall, you say it's 120 volt, but it's actually sine wave, right? That's coming out. So even the 120 volt that you've got coming out of the wall is a dynamic system. We'll look a little bit at block diagrams and transfer functions, because those are kind of a simplified way to represent any system. We'll look at first and second order systems. And in first order systems, we don't even need to solve with differential equations. And you've done that before. Remember time constants? R over L time constants, or RC time constants? That's just formalized like first order circuits. But in this class, we'll actually be able to show you the math of how to actually come up with those equations for first order circuits. You probably haven't seen second order circuits because they're too complicated to be able to analyze without differential equations. And so we'll do second order systems using, more math techniques. So this was already the stuff in the syllabus, but course outcomes is really important because it's for ABET, which is accreditation. And you all should care very much about accreditation because if you graduated with an EET degree that was not accredited, you cannot become a professional engineer. Why do you want to be a professional engineer? I don't know. Most people, it usually means you can get to certain management positions. Like Adam Benedict, for example, he's a professional engineer and he can run the group, not because a professional engineer is a better manager. It just means that they can stamp drawings in certain states, wherever they're licensed professional engineer. And so doing that gives you additional responsibility, but usually it means you're a better quality engineer. And so becoming that professional engineer is a really big deal. And the other advantage of it, of being a professional engineer, is you can hang your own shingle. Paul's engineer. I can hang a shingle that says that. If you don't have a professional engineer's license, you can't have a business name, a business with a title of engineer in it. That's regulated by laws. And in some cases, in the state of Maine, this was a few years ago, they cracked down on somebody who had a business card that said they were a senior engineer, but they weren't a professional engineer. And so they notified the board that, hey, this person has in a business card that they're a senior engineer, but they're not a licensed professional engineer. And so there was a lot of discussion about the term, and it ended up that they can use that in your business card title, because that's just a title of a position, doesn't necessarily convey that they're a licensed professional engineer, but there are some boards that take this way more seriously. So it's on the process of licensure. So it's a really good thing. So that's why ABET for us is really big. And we're actually going up for our ABET accreditation renewal because we were accredited for 6 years. So we're going up for renewal coming this summer. So the EET faculty will be busy doing that. But these are some of our ABET stuff that we want to do. Here's the grading scheme. Again, this is all in the syllabus. You can take a look. So our homeworks, 3 prelims, 1 final. I've already got the date and time for you. I apologize if that's inconvenient, but I have nothing to do with the date and time. That's all set up by student records. You just tell them whether you want a final or not, and they figure out the date and the schedule. So if you have any issue with that date or schedule, you need to talk to student records because I had this much to do with it, nothing at all. So, and even student records, you go to the website, they actually have this, the financial, the schedule for final exams already in there. 20% labs, very important. I encourage you all to work together. The best way you can learn the material is to teach it. If you understand it so well that you can teach it to somebody and they can understand it, wowzer, you've got it. They've got it. You are in tip-top shape. So working with somebody or working together on an assignment does a lot of things. It gives somebody who understands the material pretty well, it gives them a second chance to cover the material, which means I'm getting it better. When I was an undergrad student, I used to always try to tackle my homework first, and then I loved helping out other students. I loved teaching it, but I also got better and better at the material. So I found that that really helped me with my studying. And the other thing it helps you with is motivation. I don't want to study tonight, but if your partner's there or your partners are there saying, we got to study, we got to do this, they'll push you, they'll motivate you. Okay, fine, let's do an hour, let's do a couple hours, let's just knock this out instead of going to play Call of Duty or something like that. No, just makes much more sense to do it that way. Is that not the cool game anymore, Call of Duty? I don't know, what's the latest, greatest game that's out? What is it? Battlefield 6? Oh, Battlefield 6. Okay. So instead of going to play Battlefield 6, thank you for that, because I didn't even know there was Battlefield 1 through 5. So knowledge for me. The idea is that you can still do all that stuff. You just get your stuff done. And that's another thing we talk about a little bit too, time management. Get your stuff that you have to get done. That's important to get done early. So I've been trying to teach this to my 9-year-old, which is like, yeah, exactly. It's pressure, but he was kind of dealt a bad deck of cards. So he'd been in a private school his entire learning until he went to 4th grade. And then we went to a public school. So He had never been in a public school, had never taken a formal test. And so when he walks into fourth grade, one of the teachers pulls him up to the room. Hey, you need to take this math test to see if you can are accepted into the accelerated program, which just means you have knowledge. Doesn't mean you're smarty smart. It just means that you've got some background. And he'd never taken a test like that. So he did okay. He got like a 70 something, but it wasn't enough to be in the accelerated program. So at the end of the year, he scored like a 99 on this test. And they're like, you need to be in this accelerated program. So if you are okay with it, here, we'll put him in the accelerated program. We're like, yeah, okay, that's fine. And then here's two fifth grade books, because accelerated in Bangor means you just skip a grade. That's all it means. It doesn't mean you're getting more depth. It just means you're skipping a grade. So they gave us two workbooks for fifth grade math because he had just finished fourth grade and said, have a nice summer, essentially. So in the summer, he was like, do I have to do this? It's like, let's do this first thing when we get up. We'll knock it out in half an hour to an hour. And then the rest of the day, you can go do your fun stuff. So you don't have to sit there and say, how am I going to finish this? How am I going to do it? Or if he was in the middle of doing something incredibly fun with his friends, it's like, oh, I have to leave and from my fun thing because I've got to go and do my math homework. And so that's the same perspective that you may want to take too, which is try to get your stuff that you need to get done first. And one of the most important things that you need to do, what you might not realize it is, take care of your bodies. Go exercise. You get a free gym. It's a wonderful gym. It's still rated one of the best gyms in the country. And it's free. It's part of your student activity fee, but it's free. And I know it can get busy, crazy busy, but when does it get crazy busy? 3 o'clock or 4 o'clock on. It's a little bit busy in the morning, like at 5:30, because you got the really very dedicated folks. But other people, you go in at 7, maybe at 8, right before class. You get a good workout, you take a shower, you're feeling good, your muscles are kind of burning a little bit. And what do you know? You don't have to worry about how am I going to fit my workout in at 5 o'clock? I've got all this other stuff to do. So one of the best pieces of advice that's worked for me, like this morning, I got up at 4 and I lifted in my gym. It's like I've got one bar and I've got like a small rack that I can do stuff with, but for an hour, I can just, before kids get up, before my wife gets up, it's like I can just focus and take care of myself. So I don't have to worry about getting my gym workout done this afternoon. It's like, I finished it. It's already done. I don't have to worry about it. So that's one of the, if I can give you just a general life lesson, because you're all young and healthy. I'm not young. I'm relatively healthy, but it's because I've been taking care of myself, even though I don't look like it, I still, I run a 5K every other day. And I work out every other day. So I lift on one day and then I run the next day and I just alternate those days. And it just means that I have better health. I can get around. I can chase after my kids. I can go shoot hoops. I can play soccer with them. So, and I'll be 55 in 2 weeks. So not saying I look great, but I'm saying I feel like I can still compete. So anyway, that's just advice. You start these habits now when you're in college, they'll continue through. It's really tough to develop habits when you get out because you're working, you're busy. Right? You got a 40-hour a week job plus commuting and yada, yada, yada. It's much less effective for you to do that. So if you can develop these really healthy habits now, then you don't have to worry about them. And it takes like 6 months before you can set up a pattern that you'll stick with. So 6 months seems like a long time, but just like my son this summer, it's like we've got 700 plus pages of math work to do. Today's day 1. We just start one day at a time and then see where we go. And by the end of the summer, we were done. We were caught up. We actually started on the chapter, the grade 6 material because we finished a week or 2 early. So it's like, hey, we got momentum. Let's keep going. But anyway, work together, but don't cheat. You can have the same looking homework as somebody else, but it shouldn't be an exact copy. It shouldn't be a photocopy. You can say, I worked with this person, but it should still be in your own writing and it should be your own format. Like how you pose things or how you represent things. And why is that important? Because you've got to learn it yourself. If you're just copying from somebody, that's not learning it. That's just copying. And biggest disservice you do is to yourself. Because if you get a grade in here, let's say you get a B, the companies that hire our students have expectations of what our students know. If you get out and start working and you don't know something, you get fired. So you'd rather learn now when it's just going to doink you a point or two or a letter grade or something like that on homework, as opposed to learning in an industry when your boss is yelling at you because they expect you to be able to do something because you have this degree and you can't, and they're disappointed in you and they get rid of you. But then more importantly, they also don't want to hire our students from EET. They don't know anything. They can't do this stuff. So we're not going to hire ET students anymore. So it does a disservice to you and it does a disservice to the program. So really, cheating hurts a lot of people and including yourself. So avoid doing it. Here's some strategies to solve problems. And I do the same flow chart with my son, which is read the statement. See if you can understand what the statement is asking you. Highlight what's important and what's irrelevant, or what you think is important and is irrelevant. Then get the goal. I'm trying to solve for the slope of a line. Gather your information. So that's a highlighting process, right? What's the important stuff? Now you're going to devise a plan. What type of approach? Are you going to use KVL? Are you going to use Thevenin? Are you going to use superposition to solve this? That's devising the plan. Once you've got that, now you develop your equations to actually solve that. Do you need more information? Do you have enough? If I do, then I got to go back to, if I don't have enough, then I got to go back to the problem and figure out what stuff do I need to add. If I do have enough, then I'll try to come up with a solution. And this is the most important part that almost everybody skips. Is the solution reasonable? If I've got a bunch of resistors that I'm putting on a breadboard and my calculation results in 7,262 amps, that's probably a mistake, right? Because those breadboards are only designed for like 100 milliamps and you're going to run 7,000 amps through it. So coming up with sort of a feel if the numbers make sense is really, really helpful. If the numbers make sense, you're done. If not, go back to if you need additional information, rethink it, and then try a solution again. So what are we going to do? Hopefully, we're going to analyze, so determine what the problem is. So a lot of word problems, a lot of trying to figure out what's important and what's not important. And then you get to do design. So that's a big change from some of the ET classes that you've done so far. Usually you're asked to analyze something, but now I'll ask you to start to design things. If I give you some performance characteristics, can you design a system to meet that? And I'm not saying you haven't done that exclusive, you've never done that before, but we're really trying to switch it up so that you can actually do some design. Then you develop. So we want methodical. I don't want to turn you into robots, but sometimes that's the best way to do it. Because if you have a methodical approach to solving things, I can help you. A colleague can help troubleshoot your work. If I can't figure out what you're doing, then I can't help you. And so that's one of the most important things you can do is write things down in a logical order, that approach, so that you follow it and it makes sense. Every time you do approach and it makes it easier for it. You need to determine any goals, plural. Identify the necessary information. Again, you're going to get a lot of information in the real world. So figure out what's relevant and figure out what relevant is very good. And then competency. That's 7,251 amps. Doesn't take a lot of competency to do that. But once you start looking into, more refined and your answer is closer, does the answer make sense or does it not make sense? That's where the competency comes in. So we're going to refine your understanding, right? Didn't even say review. I said refine. What does refine mean? It's polishing, right? Making something smoother or sharper or more brilliant. So helping you get a better understanding of your circuit analysis. This is a little bit mathy class, a math intensive class. So we're going to do some improvement, not trying to teach you math, but maybe go back and do some math and then do some derivatives and integrals so that you get better. But more importantly, so you can understand these fundamental concepts, because again, all our circuit analysis, there are differential equations. We'll do Laplace and Fourier, and we'll do the FE. Does everybody know what the FE is? Fundamentals of Engineering exam. You all have to take it. At this point, you should all have to take the FE. You don't have to pass it, but you have to take the FE as a graduation requirement. And we do that again because you can get financial aid for the test. But getting your FE, all that means is that you've met this minimum qualification. And it's a really good thing to have because when they hire you, if company X doesn't know anything about UMaine EET, but if you list on your degree or your resume, FE certification or EIT certification, which is engineering training certification, they're like, wow, this person has some general competency because they were able to pass this fairly challenging test. So we ask that you take it, and we have had, numbers of students that have passed it. We'd like to see a higher percentage, but, we don't have, a specific mandate to do that. Although we do have EET 405, which is a FE prep course for EET students. And so that's going to help you even more. But you can't really take EET 405 without taking this class, because you won't understand most of the material in that class. So that's a review class, not a instructions class. Okay. So that is all that I had for our introduction presentation. A little bit about me. I'm actually one of you too. I'm probably the only one. I graduated EET from UMaine many years ago, but I got a master's degree and I've been to a bunch of different schools, and our program does turn out really good engineers, because I've taken classes at George Washington University, George Mason University, taking classes through WPI, NC State. I was in their NC State PhD program for a short time, but then the timing wasn't working out, and I got A+ in their program. And so you can do anything you want from this program. Don't let anybody let you believe that EETs are second rate. We have all the abilities and the talents to do just what they do. We just focus on different stuff. You don't need to spend a lot of time doing vector calculus and triple integrals and spherical coordinates to be able to get good jobs that can answer problems, because most of those folks aren't going to be there. So, yeah. What else? Nothing else? Excited? Indifferent? Everybody hit their gym this morning? Get their gym workout yet? Just waiting, right? Trying to get your pump up. Got to get the caffeine in and little C4 or whatever that equivalent is. What's the energy drink of choice? I know Red Bull's too expensive, so nobody drinks Red Bull unless you're rich. We had a bunch of people doing Celsius last year. That was a big thing. I guess that was pretty economical. So be careful about that stuff too, because you drink 4 or 5 of those and you wonder why your heart's pumping like crazy. That might not be the best thing for you, but I get it. I understand. I don't do any energy. I don't even drink coffee, but I understand why it sometimes is a necessary evil. So, okay. Well, with that being said, I hope you enjoyed the first class. The next class, my encouragement is, please go to Brightspace and access the presentations. This circuit analysis one, you all have access to it. You can download it. And then what I recommend is, when you're taking the class, you can write little notes in the margins, so you can have all that stuff. So most of y'all have tablets. If you want to bring in hard copies, print them out, and then you can write on that. That works really well, but you should have access to all the presentations. Has anybody tried accessing them yet? They're all accessible?
Yeah.
Okay. What's that?
They work.
Good. Yeah, and they're all PDFs, so it's not like PowerPoint where you have to have a Microsoft product. They are PDFs, and you can download the reader for PDF for free. I don't even think you need the reader for PDF anymore. I think it's built into a lot of web browsers now, so. All right. Anything from TV land? Everybody good in TV land?
So far, so
good.
good.
Okay. All right. Well, with that being said, enjoy the palm trees and fun stuff, and
Yes, it's a very nice background.
thank you. Takes away from my not nice face, so. All right, y'all. Take care, and I will see you all on Wednesday. And I might see some of you guys in an hour and change, because you're in my other class. But take care, everyone.
All right.
Bye.
Bye-bye.